Hello everybody, Claudio here. This is a short video to make a correction from the previous one where I showcased a safety socket, and as a viewer pointed out, I think his name is Greg. Thank you, Greg, for commenting. He pointed out that here this is an abstract of the old design. Here, if the relay remains stuck, the socket is not detached from the mains, so it is dangerous. I actually used two relays in my design, in my previous design, and so I thought that it was unlikely that both relays remain stuck. But anyway, if this relay remains stuck, here we have the line that is in this pole of the socket, so it is dangerous anyway. So in hindsight, I decided to change the design, and this is the new one. Oh, here is missing L, N. Of course, this is an abstract of the schematic. Here we have two relays, but here we use both contact for each relay, and here the first relay connects the socket to the mains, and the second relay connects the socket to ground. Actually, here there are a couple of resistors that I haven't drawn here, to 4.7K resistor here. So if the relay remains stuck, when this closes, the socket is pulled down to ground, so the main GFCI or RCD, residual current device, intervene and remove the power from the mains. So this is a safer solution, and I implemented this. So here, this video is to show you this modification. And this is the new schematic. Here we have the input of the mains, line, neutral and protective earth. Here the magnetothermal switch that limits the current of this whole thing to 5 amps, and here the indicating lamp that indicates the presence of the mains. Here the power supply, the controller, here the main indicating light that indicates that the socket is turned on, here the socket outlet, and here the command box where the emergency on and off buttons are located. And here these two buttons have an internal indicating light that is controlled by the microcontroller, and here the two relays that are controlled by the microcontroller. And here the wiring is a little bit complex, and so I've made the simplified version. This is the simplified drawing. Here the line, the input of the mains, and here this is the RL1, the relay, and this RL2. Here we have two resistors that, for the sake of simplicity, I haven't drawn here. That's it. It's easier to understand here. As you can see, when this closes, this must be open, and vice versa. So after having changed the hardware, here it is necessary to change the program. So let's see what to change. As a reminder, this program is the software is used to program a device. This is like kind of Arduino, but it has already its buffers for input output and communication bus 485 RS485, and it is designed to make automation projects like this one. I have already changed the names of the two outputs that control the relays to reflect the changes of the circuits. Here again the circuit RL1, RL2. I have to change the program, so this relay will open before this one. So here I have to remove RL1 from here. First I have to release this and then release this one. This is not released and this is released, or vice versa, so this would prevent short. Even here, when everything is stopped, I have to do the same thing. Alright, now I have to start with the delay. First, when we end the cycle, we start a timer, and let's say we wait half second, 500 milliseconds. So here we go. We have here the when the cycle ends, the socket on light, starting light, and the socket RL2 are closed. This means this one is energized, so the contacts will open here, but the contacts are not yet closed here. The timer is started, and when the timer expires, here we go, we have the timer. We turn on RL1. Alright, we have here, when the timer expires, the RL1 is closed, L1 is closed, and this is already opened. Alright, and the same thing we need to do when the cycle, when we stop everything. So first we open RL1. This one is opened. Alright, and we start timer 1, and we wait the same time. So when timer 1 ends, we de-energize RL2. So when this is de-energized, the contacts are closed, and obviously when the power goes out, all the relays are released, so the contacts here are closed and the contacts here are opened. Okay, let's program. Now a disaster will happen if we have even a little error in the sequence. Okay, let's try. Oh, raise the power. Start. Oh shit, actually it happens. Okay, let's try again. Power up. Start. All right, stop. Shit. Again. Okay, eventually I got it right. And yeah. Fine. Okay, well, the mistake was that I commanded the wrong relay, because I named the relay to the wrong output. Okay, RL0 is at output 5 instead of RL2, so that was my mistake. And then furthermore, I added a stop to the timer when the cycle ends, because if I don't do this, when I press stop, or when I press start and then I press stop, the timer still goes, and when it expires, it freezes the relay and causes the short. It is of course mandatory to have a GFCI or a zero current device. I got some corpses. Even the content of this video and of the previous one will be put in my website with complementary information such as schematics and more information. And it will take some time because I'm still moving from the old website, but it will be there. And for now, that's all, folks. Thanks for watching. See you next time. Bye.